Chandra X-ray Observatory, previously known as the Advanced X-ray Astrophysics Facility, is a space observatory launched on STS-93 by NASA on July 23, 1999. Chandra is sensitive to X-ray sources 100 times fainter than any previous X-ray telescope, enabled by the high angular resolution of its mirrors. Since the Earth's atmosphere absorbs the vast majority of X-rays, they are not detectable from Earth-based telescopes. Therefore space-based telescopes are required to make these observations. Chandra is an Earth satellite in a 64-hour orbit, and its mission is ongoing as of 2014. Chandra is one of the Great Observatories, along with the Hubble Space Telescope, Compton Gamma Ray Observatory, and the Spitzer Space Telescope. The telescope is named after astrophysicist Subrahmanyan Chandrasekhar. History: in 1976 the Chandra X-ray Observatory was proposed to NASA by Riccardo Giacconi and Harvey Tannenbaum. Preliminary work began the following year at Marshall Space Flight Center and the Smithsonian Astrophysical Observatory. In the meantime, in 1978, NASA launched the first imaging X-ray telescope, Einstein, into orbit. Work continued on the AXAF project throughout the 1980s and 1990s. In 1992, to reduce costs, the spacecraft was redesigned. 4 of the 12 planned mirrors were eliminated, as were 2 of the 6 scientific instruments. AXAF's planned orbit was changed to an elliptical one, reaching 1/3 of the way to the Moon's at its furthest point. This eliminated the possibility of improvement or repair by the Space Shuttle but put the observatory above the Earth's radiation belts for most of its orbit. AXAF was assembled and tested by TRW in Redondo Beach, California. AXAF was renamed Chandra as part of a contest held by NASA in 1998, which drew more than 6,000 submissions worldwide. The contest winners, Jatila van der Veen and Tyle Johnson, suggested the name in honor of Nobel Prize Euro-winning Indian-American astrophysicist Subrahmanyan Chandrasekhar. He is known for his work in determining the maximum mass of white dwarf stars, leading to greater understanding of high-energy astronomical phenomena such as neutron stars and black holes. Originally scheduled to be launched in December 1998, the spacecraft was delayed several months, eventually being launched in July 1999 by Space Shuttle Columbia during STS-93. At 22,753 kilograms, it was the heaviest payload ever launched by the shuttle, a consequence of the 2-stage inertial upper stage booster rocket system needed to transport the spacecraft to its high orbit. Chandra has been returning data since the month after it launched. It is operated by the SAO at the Chandra X-ray Center in Cambridge, Massachusetts, with assistance from MIT and Northrop Grumman Space Technology. The ACISCCDs suffered particle damage during early radiation belt passages. To prevent further damage, the instrument is now removed from the telescope's focal plane during passages. Although Chandra was initially given an expected lifetime of 5 years, on September 4, 2001 NASA extended its lifetime to 10 years based on the observatory's outstanding results. Physically Chandra could last much longer. A study performed at the Chandra X-ray Center indicated that the observatory could last at least 15 years. In July 2008, the International X-ray Observatory, a joint project between ESA, NASA and JAXA, was proposed as the next major X-ray observatory but was later cancelled. ESA later resurrected the project as the Advanced Telescope for High-Energy Astrophysics with a proposed launch in 2028. Discoveries. The data gathered by Chandra has greatly advanced the field of X-ray astronomy. The first light image, of supernova remnant Cassiopeia A, gave astronomers their first glimpse of the compact object at the center of the remnant, probably a neutron star or black hole. In the Crab Nebula, another supernova remnant, Chandra showed a never-before-seen ring around the central pulsar and jets that had only been partially seen by earlier telescopes. The first X-ray emission was seen from the supermassive black hole, Sagittarius A, at the center of the Milky Way. Chandra found much more cool gas than expected spiraling into the center of the Andromeda Galaxy. Pressure fronts were observed in detail for the first time in April 2142, where clusters of galaxies emerging. The earliest images in X-rays of the shock wave of a supernova were taken of SN 1987A. Chandra showed for the first time the shadow of a small galaxy as it is being cannibalized by a larger one. In an image of Perseus A new type of black hole was discovered in galaxy M82, mid-mass objects purported to be the missing link between stellar-sized black holes and supermassive black holes. X-ray emission lines were associated for the first time with a gamma-ray burst, Beethoven burst GRB 991216. High school students, using Chandra data, discovered a neutron star and supernova remnant IC 443. Observations by Chandra and Beppo Sachs suggest that gamma-ray bursts occur in star-forming regions. Chandra data suggested that RxJ 1856.5-3754 on 3C58, previously thought to be pulsars, might be even denser objects, quark stars. These results are still debated. Sound waves from violent activity around a supermassive black hole were observed in the Perseus cluster. TWA5b, a brown dwarf, was seen orbiting a binary system of Sun-like stars. Nearly all stars on the main sequence are X-ray emitters. The X-ray shadow of Titan was seen when it transited the Crab Nebula, X-ray emissions from materials falling from a protoplanetary disk into a star. Hubble constant measured to be 76.9 km/MPC using Sunyaev-Zeldovich effect. 2006 Chandra found strong evidence that dark matter exists by observing supercluster collision. 2006 X-ray emitting loops, rings and filaments discovered around a supermassive black hole within Messier 87 imply the presence of pressure waves, shock waves and sound waves. The evolution of Messier 87 may have been dramatically affected. Observations of the bullet cluster put limits on the cross-section of the self-interaction of dark matter. The Hand of God photograph of PSRB 1509-58. Jupiter's X-rays coming from poles, not auroral ring. A large halo of hot gas was found surrounding the Milky Way. Extremely dense and luminous dwarf galaxy M60 UCD-1 observed. On January 5, 2015, NASA reported that CXO observed an X-ray flare 400 times brighter than usual, a record breaker, from Sagittarius A, a supermassive black hole in the center of the Milky Way galaxy. The unusual event may have been caused by the breaking apart of an asteroid falling into the black hole or by the entanglement of magnetic field lines within gas flowing into Sagittarius A, according to astronomers. Technical description: unlike optical telescopes which possess simple aluminized parabolic surfaces, X-ray telescopes generally use a Walter telescope consisting of nested cylindrical paraboloid and hyperboloid surfaces coated with iridium or gold. X-ray photons would be absorbed by normal mirror surfaces, so mirrors with a low grazing angle are necessary to reflect them. Chandra uses 4 pairs of nested mirrors, together with their support structure, called the high-resolution mirror assembly. The mirror substrate is 2 cm thick glass, with the reflecting surface of 33 nanometers iridium coating, and the diameters are 65 cm, 87 cm, 99 cm and 123 cm. The thick substrate and particularly careful polishing allowed a very precise optical surface, which is responsible for Chandra's unmatched resolution. Between 80% and 95% of the incoming X-ray energy is focused into a 1 arcsecond circle. However, the thickness of the substrates limit the proportion of the aperture which is filled, leading to the low collecting area compared to XMM Newton. Chandra's highly elliptical orbit allows it to observe continuously for up to 55 hours of his 65-hour orbital period. At its furthest orbital point from Earth, Chandra is one of the most distant Earth-orbiting satellites. This orbit takes it beyond the geostationary satellites and beyond the outer Van Allen belt. With an angular resolution of 0.5 arcsecond, Chandra possesses a resolution over 1,000 times better than that of the first orbiting X-ray telescope. Instruments. The Science Instrument Module holds the 2 focal plane instruments, the AXAF-CCD imaging spectrometer and the high-resolution camera, moving whichever is called for into position during an observation. ACIS consists of 10 CCD chips and provides images as well as spectral information of the object observed. It operates in the range of 0.2 to 10 keV. HRC has two microchannel plate components and images over the range of 0.1 to 10 keV. It also has a time resolution of 16 microseconds. Both of these instruments can be used on their own or in conjunction with one of the observatory's two transmission gratings. The transmission gratings, which swing into the optical path behind the mirrors, provide Chandra with high-resolution spectroscopy. The high-energy transmission grating spectrometer works over 0.4 to 10 keV and has a spectral resolution of 60 to 1000. The low-energy transmission grating spectrometer has a range of 0.09 to 3 keV and a resolution of 40 to 2000. Gallery. See also: Great Observatories Program, List of space observatories, New Star, X-ray astronomy. References. Further reading. External links: Chandra X-ray Observatory at nasa.gov, Chandra X-ray Observatory at harvard.edu, Chandra podcast by Astronomy Cast.